go to timber bridges. And timber bridges, we've done a lot of work on timber bridges for non-destructive evaluation, everything from visual inspection technologies through laser technologies. I didn't incorporate that because that's still in a research phase, but just some beautiful work. Most of our work with timber bridges has been in cooperation with our industry colleagues, such as the American Wood Council and some of our wood manufacturers and manufacturers of bridges, but also with the Federal Highway Administration. They've been an outstanding partner with us on this. They come to the laboratory on a pretty much regular basis because of our wood technology and wood engineering knowledge. So variety of bridges from single span, multi-span, stringer bridges, solid sawn, glued laminated bridges, different species, just a whole realm of activities on it. So, and they have funded over the years a whole series of looks at studies looking at various non-destructive evaluation technologies and inspection methods for timber bridges. I'm going to just show you one of the ones we did recently. This is a timber bridge that was in Gaithersburg, Maryland. It was constructed in 1946. It's neo-laminated decks, and it was in a 3-span configuration. The deck was replaced in about 2000. This goes back to what I talked about with the Douglas fir and the treating issue. Some of the concerns were there was significant checking and hence exposure of the internal wood and some of those members in the timber substructure. And there was considerable uncertainty about how that's going to affect the load rate analysis and their ultimate load carrying capacity. So what we did is used a lot of different techniques, but I want to leave one here with you that I think is very, very important. Looked at the size of the members, did micro drilling assessment, but one of the techniques we found out was very simple, but still very useful, was simply using a metal feeler gauge that you can get in any of your hardware stores or auto repair stores to determine the extent and the depth of the checks. That depth is a really important thing when it comes into the amount of preservation that went in there. And also when we talk about designing fasteners and connection systems, how well the wood's going to behave or what we have to take into design in those designs. So anyway, it's a really important thing. What we found out was that there was some deterioration. We actually brought some of those members back here and built up some of those bents and actually tested them. And we found out that in some cases the actual load carrying capacity was diminished, mostly because there was deterioration on the ends of some of the members for just like we talked about before. There were some larger splits that had developed. It had compromised the preservative wood envelope, if you will, and as a consequence we had water intrusion, decay, and as a consequence deterioration of the wood and a significant reduction in their load carrying capacity. So really great thing. I will tell you that we're doing some other work in the timber bridge area, and it's in the Wood and Timber Condition Assessment Manual that I didn't publish or bring out here. We've recently embarked on a study on historic covered bridges where we're actually using laser technologies to get as-built records of timber bridges. And so we've used some laser scanning of overall bridges, and now we've got a pretty good technology in our toolbox to help us to get as-built records of those. I didn't bring that up today. If you want another webinar on it, we'd be happy to do it, but some really interesting technology there. Buddy, I'm getting close to the end here. I want to open it up to questions. Where can you find information on evaluation, maintenance, and repair of existing structures? I'm going to close out and go back to these two really important documents for you folks. The one on the right is the Wood and Timber Condition Assessment Manual. Everything I covered today plus some is in that. It's available in a PDF format. Please use it. Take it, and it's going to cover a lot of things I probably overlooked or probably understated or misstated. Really good document, and it's been well reviewed and well received. Ironically, we had great support from AWC, American Wood Council, and Buddy and his staff at reviewing it and providing input, and we sure appreciate that, and hopefully you enjoy it and find it useful. On the cover, you'll see some of the things we have done inspections of, just their artist rendition, but there's old Ironsides. We recently did some work for the city of Beijing in China and the Cultural Ministry Department in the city of Beijing, to come up with inspection methodologies and assessment procedures for all their historic structures, which is a very interesting effort, and we'll be publishing that soon. Down on the bottom is a historic trout rearing station that's on, in Upper Michigan, that's on the site of the trout rearing station where the last grayling trout was caught east of the Mississippi River, so it's pretty cool. CCC built building in the 1930s. And up in the top is that mummy coffin I spoke about. If you want, there's a publication on our website that talks about that coffin in detail and what we did and some of the technologies. If you want to see it, check on the website of the Nelson Adkins Museum of Art, and there was a whole display on the mummy coffin. Excellent example of using wood in an arid environment, keeping it dry, and having wood last indefinitely if you really watch what you're doing with it. The second document, and again, it's a great one to have in your back pocket, is the Wood Handbook. I went through a lot of that with you, or just hit some of those chapters. Please use it. It's there. We get a lot of downloads on it. It's been reviewed extensively, and it's really a nice compilation. I don't know if I told you this, but that document has evolved. It was first published by the Forest Products Laboratory in, I think, 1935. And I don't know what edition we're on now. I know we named this our Centennial Edition because we prepared it in the anniversary of our first 100 years of service. So, but there's various versions of it out there. I recommend you get the latest, and it is available off our website. So with that, I'll turn it back, I think, to Marcy.
Actually, Bob, it's going to be me, and we're going to do some Q&A now. We've got plenty of time to work through questions, and the questions are rolling in. So no particular order, but one of the last ones you finished up with showed some examples of splits and checks in the columns. Talk a little bit.
I'm sorry. I am going to interject here just real quick.
Sure.
I do want to remind everybody to please stay on for the questions and answers, because we are just at 3:36. So if you do leave now, you will not meet your requirement for the time.
Great, thanks, Marcy. Yeah, so folks, stick around. This will be part of the seminar to get you your 2 hours of credits. But Bob, on this slide, talk a little bit about the grading rules that allow splits and checks and shakes in timbers like this. And actually, when they're graded wet or green, anticipate this occurring. And then how do you begin to determine when that exceeds the grade rules and it begins to affect the strength or load carrying capacity of these members?
Boy, that's a loaded question. That's a tough one. Yes, let's go back. When these members are first graded before they're put in a structure, and if you go to the chapter, it has within that they have specific guidelines for various grades and grade combination of what kind of checks, depths that are allowed for various grades, and those grades will actually determine determine the various allowable design values. Generally speaking, and they vary based on species and species groupings. Generally speaking, the fewer the number and the smaller the check and the split, the higher the grade you're going to get and the higher allowable value, generally speaking. In the field, my number one concern is not so much in where they are, but is in the their ability or their contribution to water intrusion and to decay. And that's why when I see things like that, while they are important in and of themselves, what's more important, and I don't have a slide of it here, but in these particular ones, you could see where water came up in there, and you could see the core of those pieces or those columns were severely deteriorated, and brown crumbly wood, water damaged wood. That's what caused the major problem. And so when I see these, what's more important is following up with some kind of look into, for a better word, internal to them, whether it's an increment core, a boring device, or a simple feeler gauge to get some idea of whether there's an absence or presence of deterioration in there. To me, it's not so much that the checks are there, but it's where are they and where it could be. For example, or what it could do. For example, on this particular one, what's concerning to me on the left is that they're in there and they're so close to the ground that you're going to get a lot of moisture intrusion. You're probably, and I don't have the resolution on there, but you're going to get plant growth. You're going to get some dirt in there. You're going to get mold. You're going to get some fungal growth, and then we start deterioration. That, to me, is a bigger issue. But having said that, if you go into the chapter on, I'm not trying to dance around it too much, but it's a loaded question, and there's a lot of data on that. And it would take me a long time, but there's some examples on there on largest knots, slope of grain, let me see, estimation of dissolvable design values, checks and splits. Take a look at that. I think that'll answer the question for your specific applications better than I could over this. Is that fair?
Yeah, that's great. That's great.
Okay.
So you talked a little bit, too, about naturally durable species. So let's talk a little bit about what some of those are. And I've got some code language here about some of that, too. And then maybe we can transition over to some of the preservative-treated species that are easy to treat and which ones are maybe a little more difficult to treat. So let's talk naturally durable first.
Okay, I just, can you hear me okay? I just went to the wood handbook. I've got it right in front of me, and I want to pull that right out. Let's first talk about some species of wood that are not very durable. And while I'm thumbing through here to get those, some of the woods that are not very durable would be things like aspen, cottonwood. Some of those lighter, whiter woods are really not very durable, and as a consequence, when I see those in a structure, I really get pretty concerned. If you look at the wood handbook in Chapter 14, Biological Deterioration of Woods, on Table 14.1, it's titled Grouping of Some Domestic and Imported Woods According to Average Heartwood Decay Resistance. The heartwood of the tree is, when you look at a log, it's usually the darker part, and what we call a sapwood is the outer part. The heartwood is usually much more decay resistant than the sapwood. And the reason that is usually the heartwood will absorb up some natural chemicals, and those chemicals are what we call extractives, add to the decay or biological attack resistance. But just to give you some ideas here, very resistant species, black locust. You've all maybe seen that or not, but it's a very resistant species. Redwoods, especially old growth, black walnut. Most of the white oaks are very decay resistant or resistant. Some of the cedars, western red cedar, eastern cedar, red cedar, white cedar, those are very resistant. Bald cypress, you're probably not going to see much of that. Kind of moderately resistant, most of your pines, your southern pines, your redwoods, your Douglas firs, those are what we would call moderately resistant. with no treatment. So if you keep them dry, they're probably in pretty good shape. Slightly or non-resistant, your aspen, your beeches, your lower density woods, cottonwoods, some of your true firs, some of the pines we didn't list that are probably not used much for structural applications anyway. Right. Yellow poplar, balsam, those kinds of woods are not very decay resistant. So, but there's a whole table there, and look at them, and there's some really good, a lot of details on it, and there's some good research behind it if you want the exact publications.
Yeah, so it does. And just to clarify from a code standpoint, the code is very specific about requiring 90% more or more of the width of each side being heartwood, and then the following species listed in the code are as decay resistant are redwood, cedar, black locust, and black walnut. And then termite resistance includes redwood, Alaska yellow cedar, eastern red cedar, and western red cedar. So those are specifically listed in the code. Let's talk a little bit about preservative treatments then. I think you mentioned Doug fir. Talk a little bit about the refractory species like Doug fir, hem fir, the incising that's done to get the preservatives to penetrate.
Sure. Okay. Well, for you folks, just to make your life easier, it's Chapter 15 in the Wood Handbook. It's devoted just to wood preservation, wood preservatives. It's probably one of our most used chapters, most widely downloaded. To answer your question, buddy, the structural wood is composed of a bunch of fibers. So think about a bunch of straws all glued together, parallel to each other. That's kind of what the wood looks like. And if you look down that, you'll see these holes in there. And that's what we call a luminaire, but each piece of wood has a lot of those holes in there. Some of the species of wood allow water or liquids to penetrate down in there and then diffuse out or diffuse in. Some do not. For example, we just talked about how the white oaks are very decay resistant, and in the code they're listed as a decay resistant species. The reason the white oaks are is because on those holes or those lumens, there's certain growth characteristics that are basically skin-like structures that go across those holes and will not let the water penetrate or the preservative penetrate in. So they don't take preservative well, but the flip side is they don't absorb moisture that much, and as a consequence, the decay doesn't get a chance to go. So that's part of the reason for the oaks. Now, for our structural woods like Douglas fir, Buddy brought that up. Douglas fir is a great material. It's relatively low density, but it has great performance characteristics, great structural material. But it has those tubes all lined up, and they're pretty open on the ends, which is a good thing. But if I go transverse to those, so across one of those tubes, they have little holes in the side of those tubes. And, excuse me, in those holes is a little flap-like structure. And when we dry the wood out to prepare it to be used in a structural application, that flap closes up that little hole. And as a consequence, you can't push water through it. So, as I showed in some of those earlier slides, just a big timber of Douglas fir, if I tried to force liquid in from the sides, I would have a very difficult time. So one of the things that the manufacturers of these do is a process we call incising. And incising simply means they have a device that actually puts slits along the length of the piece or into the wood, and they allow that chemical to go into those slits and then permeate out a little bit more. So that gets it deeper into the Douglas fir. It's been a problem for many years with the species, but if they're done right, if it's maintained right, and the other thing is on Doug fir, if the end grain is sealed correctly and maintained seal, it's just done. It does very well.
Yeah, along those lines, talk a little bit about once a member is field cut, what are some field applied treatments that can be used and some best practices?
That's a good question, once we do field cutting on those, and I'll give you my first experience with that was on a deck. Somebody was so proud of the fact that they bought treated wood and they handled it well, did all those beautiful things to it. They cut the ends off, and all I saw was unexposed wood. And I said, boy, we got a problem, because what happens is with unexposed wood, it'll shrink and swell a little bit on that end when it gets wet or dries, or vice versa. But it'll move, we'll get splits, and then that thing will get wet, it'll absorb that water up in there, and then we'll get decay in there, and it'll just march its way right down the piece. What I recommend on any of these, anytime that barrier is broken, even with an increment core, if we break one of those, I recommend a field treatment. And a field treatment can be as simple as taking, and I'm not a chemist, and I don't want to pretend to be one. I would look in the wood handbook, but what I would do is get some preservative material that's available, and I really recommend the ends are soaked. I recommend if there's any big holes driven for connections, fasteners, I recommend a field treatment on there, because again, anything that compromises that, in essence, envelope opens up the idea or the potential for decay and deterioration.
Yeah, the code talks about copper naphthenate as one type of field
copper naphthenate is very good.
Yeah. So
and there's others, and there's constantly evolving on there. But the big thing is, what I tell people, practical people in the field, is when you see a treated member, it usually has a color to it. Green treated, used to be penta and creosote, and then the dark black was creosote. That's great. That tells you there's treatment in there. When you see any kind of wood in there that is untreated, we have a potential, and you have to do something to treat that. So anytime you've broken that envelope in any way, shape, or form, you've got to do something to do a remedial treatment.
Okay. So I want to transition then to some repair discussion, but we've had quite a few people asking about that Air Force trestle and what it was used for. Do you know the background on that? I've heard, but I'm not.
What I heard, from what, it's before Buddy and my time, so I'm getting it from the literature, and I know some of the guys that worked on it. My understanding of it is that structure was built by the Defense Department in the middle of the Cold War, and it was built because they wanted to have a structure where they could take aircraft and subject them to an electromagnetic force field without having the structure react. Right. And wood will not react to it. It's not going to react to that. So wood was chosen because of that. From what I understand, it's in Don Neal's paper, they actually used a wood phenolic-based bolts in their body, and with the whole idea they could expose that to electromagnetic force field, and it would not be influenced by the structure itself. That's what I was told.
Yeah, that's my understanding as well. So that's consistent. Good.
It's very consistent. Now the neat part of that was, and where I go back to it, and Don Neal was the consulting engineer on it. He was out of the Portland, Oregon area, great consultant, a great guy. One of the first guys to really do some, what I'd say a little bit advanced work on inspection methodologies. He's since passed, but he put together a really good paper on it, and it's cited in the Condition Assessment Manual. So if anybody wants, they can either get it out of there, or if they can't find it, I can find it for them.
Perfect. Thanks. Well, let's talk a little bit about repairs. So a lot of questions about epoxy repairs. Share a little experience on, from all the work that you've done about epoxies and various repair options for decay and things like that you have some experience with.
Sure. First, before I do, Buddy, what's your recommendation on a code level for repair work for epoxies?
Well, it's really kind of an engineering-based approach.
Judgment call.
So yeah, there's nothing specific that I'm aware of in the code that addresses epoxy. So it's based on what the manufacturer's literature provides, and then the engineer's judgment with that.
Okay. Well, my experience, that's good, because that's been my experience. Here's my experience with them. First of all, when we get into any kind of decayed wood, it's much like a tooth in your mouth. You've got to get the decayed material out of there, because any type of adhesive or even a paint will not stick well or adhere well to decayed wood. It just does not. Even if it did, you would usually the decay will extend at a microscopic level into the good wood. So you've really got to bore that out or clean the surface before you provide any kind of adhesive to it. That's number one, and you got to be able to verify that. So that's number one. The second thing is, for a lot of these, there's not been a lot of research published on the effect repairs or various repairs have on residual capacity. Most of it's been engineering judgment call. There's been some very good work done, but because of that, what I recommend is, if the member's in compression, so if we have a column and we want to do compression on it, I'm fairly confident that with repairs, because the joint or the is going to be in compression. Where I get very concerned is where we start to do those repairs in any kind of a tension mode. So bottom chord of trusses, bottom chord of large timbers in bending, anything that has tension perpendicular to the fiber axis, I get a little concerned about. So I know what the manufacturers recommend, but I'm very cautious about that, just because there's been not that much published on it. Now, having said that, there are some good publications out there. If you run into that and you want information, contact one of us here at the lab and we can dig those out. We have not personally done a lot on use of epoxies in repair, but we sure know where to get the information for you. So I'm going to be very cautious, is all I'm going to say, because anything where we've got any kind of deterioration or water issues, usually any type of material, they don't bond well, and that causes a problem. Second thing is with wood structures, and especially ones you're going to be exposed to exterior applications. A lot of these we design so that the wood can shrink and swell and move a little bit. We're going to get differential shrinkage when we put large epoxy patches in there, and that, if we get large moisture swings, we're going to get major stresses that build up between the epoxy fix and the wood, and that usually will result in some pretty severe shear stresses at that glue line, and you'll get some failures. So again, I'd be very cautious of it. There's not been a lot of work done looking at the differential shrinkage of those things and how that affects residual capacity. So the net result to me is be very cautious of those. Other repairs that I've been involved with, well, I can tell you there's a really good paper on this. Back in the 1990s, we did some work for the Defense Department. Most of the minesweepers in the Gulf are over in desert, that were used in Desert Storm, are wooden hulled, and they're glued laminated oak, which is great, but they had some problems with the motor mounts. Bottom line is there was some splitting that went on. We recommended a field fix that just comprised of stitch bolts, pulling them back together, and they performed very well. No adhesive. It really didn't make any difference whether there was an adhesive or not. Now, that's a very specific application, kept dry, even though they were underwater. The interior members were quite dry. So we didn't have differential shrinkage patterns, and we didn't have that type of activity, but that worked very well. So that's about, a lot of the things I get on the rehab area are what I'll call gross errors. Like I say, cutting out members, cutting cords out of trusses, just gross things. And those require engineering judgment calls on how to fix them. And in some cases, there is no good fix.
Right.
Does that make sense?
Yeah, it sure does. So let's wrap up then with a little more discussion about grading existing lumber and timbers. Quite a few questions about that, and not everyone in our audience is going to be a certified grader. So talk a little bit about what some of the options are there, and maybe kind of your experience with, do you have to be able to see all 4 sides, or if you can see 3 sides, is that sufficient? And if those questions are better suited to a certified grader, then we can just say that.
That's a good thing. Well, first of all, there's a whole chapter devoted towards visual grading and coming up with allowables in the Timber Condition Assessment Manual. Get in. I just recommend anybody go into there and look at it, because a lot goes into the visual grading. Bottom line is, it would be best to have access to 4 sides, but not necessarily, because if you got access to 3, at least, I'm thinking now, buddy, on light frame, you can get an indication whether there's or not there's split there. The bottom line on all of it is, though, if you run into problems and if there's a concern, there are several consultants in the U.S. that specialize in place grading based on visual criteria, and I always defer those to those kind of questions to those individuals so they can handle it. But the procedures they use are outlined in the Condition Assessment Manual.
Great. Well,
Okay.
Bob, that pretty much takes us to the top of the hour, and you've certainly done a great job for us today. I want to thank you for your sharing your expertise with us. I'm going to ask Marcy if she would come back, and we'll let everybody know that the questions that we weren't able to get to verbally here, we're going to be taking a look at those and have some of our help desk staff try and get some answers to the rest of those questions. So, Marcy?
Absolutely.